What will happen if I fall into a black hole? Well, I would probably die, or maybe not. A black hole is in fact not a hole and is not black at all. Theoretically speaking, it is an area of space with an incredibly large force of attraction, gravity. It is, however, completely invisible, and so it happens that everyone calls it black. In general, it works like a huge, spherical, super space vacuum cleaner that sucks in everything that falls past its event horizon, the so-called boundary where outer space ends and the black hole begins. Even a photon of light, which as you may know is the fastest particle in the universe, cannot resist its attraction. And especially since I am just an ordinary person made up of ordinary particles, I also cannot resist its mighty lure. If I, by some incredible happenstance, came under the influence of a black hole, it would go something like this. If I fell feet first towards the event horizon of the black hole, my head, being farther away, would be attracted much more weakly than my feet, which would be closer. This is not good. Like being on a medieval rack, I would be stretched, elongated really, pulled like taffy to such an extent that my head would likely pop off. Next would come a meeting with the singularity. This is what is at the center of a black hole, its contents. Having passed the event horizon, I come under the influence of the singularity, where every bizarre, illogical, and demonic strangeness, in a very literal sense, occurs. In other words, Einstein's theories don't work here. There are no laws and no rules. All of our usual understandings of space and time cease to exist. This is something quite different, not of this world. There is our universe that lives according to certain laws and concepts, and there is the world of the singularity that brazenly ignores any laws and exists by itself, and we know nothing about it. So, theoretically, as we approach the singularity, my elongated body will continue to stretch lengthwise and continue to shrink in its transverse direction, its width, but will still not disappear altogether. And the most interesting thing is that my friend Bob, who got lucky and got sucked in just after me, is unlikely to survive until the moment when my body crosses the event horizon. It would seem to him that I move indefinitely, forever approaching the event horizon. But for me, on the other hand, everything happens in an instant. But that is not all. This scenario of my death will be relevant if what I'm interested in is the most common type of black holes. The event horizon, by the way, is also called the Schwarzschild radius, named after the scientist who first described this object with a mathematical formula. And yet, there are also special black holes. For example, a Reissner-Nordstrom black hole is also charged, and having an electric charge is known for rotating. I'll have to rewrite the whole scenario of my death if I find one of these holes. For example, the singularity in a charged black hole does not attract, but rather repels objects. What does that mean for me? Everything will be, once again, as before. My body will rush through the event horizon at a frenzied pace, constantly accelerating and stretching like chewing gum. Having passed the event horizon, I will come upon a second horizon. I will still speed up moving towards it, but as soon as I pass this second inner horizon, the singularity, instead of sucking, will start to push me away quite vigorously. In the end, what's known as a white hole will spit me out in some other universe. And you may say, what? But yes, if there are black holes, then there may well be white holes. A white hole is pretty much the same as a black one, but reversed. It does not absorb, but only emits stuff from itself. You enter a black hole in your world and come out the white one in another. One minor problem is that you will not be able to return back to the world from whence you came, although it really makes no difference at this point, as you are unlikely to have survived such a journey anyway, as you have probably already been reduced to a long, thin stream of elementary particles. So, in this sense, it turns out that, theoretically at least, there is such a thing as teleportation. There very well could be black hole, white hole pairs in our multiverse that serve as one-way doors between universes. universes. That is, the same hole is simultaneously black in our world and white in another. This nonsense is also sometimes called wormholes with teleportation, or black and white holes. Non-trivial topology explains the unusual properties of unusual black holes, through which, in fact, this universal tunnel is obtained. And so we gradually come to the conclusion that ordinary black holes and unusual ones exist, in theory. They have special properties that seem to be able to teleport you to another universe, these so-called black and white holes. And what about in practice? Nothing. You have to understand, nobody has seen anything like this with his or her own eyes. For example, in order to capture a picture of the supermassive black hole supposedly located in the center of our galaxy, we would need an incredibly powerful telescope with a lens diameter almost equal to the diameter of our planet Earth. We are unlikely to ever be able to build a telescope of this size, so scientists are racking their brains over alternative ways to create the first really true picture of a black hole. All of those images of black holes that you've seen through the years are, in fact, just artistic interpretations. That is, they are the vision of some particular artist and do not necessarily correspond to reality at all. Despite the absence of real pictures, scientists today are more confident than ever that black holes do really exist. In all, about 50 objects have so far been found in our galaxy that behave like black holes. The mysterious thing in the center of our galaxy is the most likely candidate for the role of a black hole. It has a mass of about 4.3 million solar masses, and the radius of the event horizon is about 1 million kilometers. Something in the center of the famous massive quasar M87 is another illustrious candidate for the role of a black hole. Its mass is estimated at about 4 billion solar masses, and the corresponding radius of the event horizon is about 1 billion kilometers. So it is more than likely that black holes do in fact exist, and more scientists are trying to prove this. But black and white holes, or wormholes, on the other hand, are something more rare and more mysterious than even unicorns or elves. They are possible in theory, but we do not have even the slightest hint of proof of their existence, as opposed to simple black holes. But whatever it is to believe in what they are is infinitely more interesting than to say that all of this is nonsense and fiction. Put likes and subscribe to the channel. See you next time.